channel. Now we are going to discuss about adaptive design pattern in theoretical using some real life examples and real time technical examples. In the next video, we will try to cover how to write a simple program for implementing adaptive design pattern using Java. So first, what is adaptive design pattern? So if you think about adapter, you would have come across this name in your life many times. So you would have intentionally known about this, sometimes you have unintentionally, you would have used the adapter for solving your real-time problems. So we'll try to cover those problems using real-life examples. So the definition between it falls under structural design pattern. So there are three types of design pattern. It falls under structural design pattern. You would get the idea why it falls under structural design pattern when we actually implement a simple program for adaptive design pattern. So that would be covered in the next video. Please try to watch that video also. It acts as bridge between two incompatible interfaces. So for example, we will try to cover this using real life examples. Suppose if you are using MacBook Pro means, so what you would have observed is there won't be any USB ports at all. So there will be only USB-C port. So this is the USB-C port and these are USB port. If you want to connect this USB port to our MacBook Pro means, what you need to do is you need to buy this adapter. This will convert this USB to USB-C. So what we need to do, we need to just insert this in the adapter port and it will convert this USB to USB-C. So this is one of the important examples. And the next example is memory card reader. If you are using any laptop or PC means, at most of the laptops and PC, there won't be any memory card reader inbuilt. So what you do is you will try to get a memory card reader for that and you will try to insert your memory card in that and you will try to connect in the USB port. So this is one of the adapters. And then is the phone adapter. If you are trying to charge your phone means, what you do is you will try to insert the pin into your phone and you will try to put the adapter in this socket. That adapter, what it do is it will try to convert the 220 to 220 volts. So basically in India 220 volt is the power that we are getting for household purposes. So it will convert the 220 volt to 9 volt for phone applications, for phone usage. So this is the real life example. These are the real life examples. We will try to cover the technical real time examples. If you are using, suppose you are writing any Java application and that Java application needs to connect with the database means, for the people you write in Java base, they don't aware about the database that is behind. For example, it can be Oracle or it can be MySQL or it can be Sysbase. Based on time, the database may convert to the advanced databases. For example, so if a new vendor is providing a better database means, the people behind that would change that that actual database thing. So we don't aware about the database behind running. You just need to write an application using some statements, some MySQL, some SQL statements. That adapter class would handle those problems, that will handle those things. For example, if you are trying to migrate from Oracle to Sysbase means, that adapter class will be changed. So this should be handled by this adapter class. So this is the real-time technical example. We will try to cover the implementation in the. This is our case. Now we are going to see what is bridge design pattern in a detailed manner using real life example and real time examples. In the next video, we will try to write a Java implementation for bridge design pattern. So in this video, we will talk about the theoretical content about bridge design pattern using some examples. So first, what is a bridge design pattern? Before going to discuss about bridge design pattern, we will see what is a bridge. Generally, the bridge is used to overcome some hurdles without knowing the internal implementation. For example, if consider this is a lake and this is a bridge. If you want to cross this lake, you can use this bridge and you can cross this bridge. You don't want to know the architecture or the materials, raw materials that are used for constructing this bridge and etc. So you just need the bridge to cross this lake. You don't want the internal architecture and the other stuff for crossing the bridge. So here this is called abstraction. So we are ignoring the internal architecture or inner details about the implementation. So similarly, if you take any software, there would be two layers. One is abstraction and then implementation. So what is abstraction? Generally, if you develop any software, if you are using any APIs, for example, if you are using Java APIs, consider the map sort example. If you are using map, or if you are using any of those collections like map, array list, and then linked list, etc., you don't want to know the inner implementation details about that. You can just call the methods like .had, .had all, .put all, etc. So the inner implementation would be taken care by the Java community. Similarly, here that is called abstraction. You don't want to know about the inner working details for using those APIs. In real life example, we can consider a fan example. If you want to run the fan, you can just switch on the fan. You don't want to know the inner technical details about the fan. For example, what are the raw materials used for what are the coil which is used in the fan, and then what is motor condition, like that. You just want to run the fan, you can just put on the fan, you can just put on the switch of the fan, it will run. So here it is called abstraction. So this bridge design pattern comes under structural design pattern. So structural design pattern is one of the important 3 categories of design patterns. This is called structural design pattern. So here the main concept, the main motto of the bridge design pattern is to allow the abstraction and implementation to act independently. So the abstraction layer can be written independently without knowing the implementation details. Similarly, the implementation can be written without knowing the abstraction details. So both can be independent. So for example, let's consider an example. So if you are a software developer and if you are using some software APIs for writing an object, for example, you are writing an object, save object, you are just calling that object, you are just calling that method called save object. This is called API. You are calling this API. So here this API, initially they have used a file to store the data, and then after 2 years what they did was they have upgraded this file mechanism to database mechanism. So they have used MySQL or some PGSQL database for storing the objects. Here these details would be abstracted to the client. So if the client can just call save object, the inner technical details can be handled by those implementing classes or implementing APIs. Here you can throw any implementation at any time without affecting the abstraction layer. So client don't want to worry about those things. If after 2 years, if a new technology comes, then that implementation can be upgraded to new implementation. So here database can be replaced with some other new technology. So here the client need not to be worried about those things. He can just call save object. The inner things can be handled by those implementing classes. And then if the client is asking about get object, similarly what would if the object was stored in file, then the object would be retrieved from file. If the object was stored in database, then from the database that object would be retrieved. So the client need not worried about the inner mechanism. He can just call those API methods. He can just abstract this client as the abstraction over the implementation. This is one of the important examples where bridge design pattern is playing a major role. And then consider another example. We will consider a real life example. If you are a retail shop owner, what you do is you would send message to the customers, to the regular customers regarding the new products whichever whenever it comes to a retail shop. So you need to intimate the customers via SMS or email or Facebook Messenger or Twitter. The only way is to, you don't have any technical knowledge regarding that. So what you do is you have bought some software for doing that. You could just click on send message. Here the inner technical details are abstracted from the implementation. That would handle all the technical details. For example, if the end customer uses mobile, then when you click on send message, then the SMS would be sent to the client. If the end customer uses email means, then this triggering button would send the email to the end client. If the end customer uses FB means, then via using messenger, this end message would be sent. So here the technical information would be hidden for the client. So the client can just call some method to use those technical information. So here the technical details are abstracted for the client. So these are some real life examples where Build Design Pattern is playing a major role. We will try to implement some sample code using Build Design Pattern in the next video. So please stay tuned. I want to discuss about Composite Design Pattern, real life example, real time examples, definition, and then in the next video we will try to implement a sample program using Composite Design Pattern. So for now we will just try to cover the theoretical information about Composite Design Pattern and using real life and real time example. So before that, this Composite Design Pattern falls under Structural Design Pattern, so which is one of the important interview point of questions. So this falls under Structural Design Pattern. And then Composite Design Pattern, the main motto of Composite Design Pattern is, if our object can be represented in 3 structure, then it can be considered as Composite Design Pattern. So you need to represent the object in 3 structure. So for example, we can consider some diagram like this. So this is your object, this is your complex object. If your object can be represented in 3 structure, then you can consider it as a Composite Design Pattern. And then the second rule is, the nodes are classified, and the second principle is, the nodes are classified into 2 types. One is composite and then another category is leaf. So this is called composite and this is called leaf. We will try to explain those things using some real life example. If you are buying any car, then the car would have engine and then the car would have tire. For that engine, it could have made up of some electrical components, and then that engine would have some valves, and then that electrical components would have some electrical chips, and then that electrical component would have some transistors. And then this is some tree structure of some complex object called car. Here, if some operation can be applied on a leaf object, then that operation should be applied on other composite and other leaf objects also. So first, before going to that, first we'll try to classify the composite and leaf objects in this complex object. A composite object would be car, engine, electrical components are the composite object. The reason behind that is, a composite object is an object which would be having some child objects. Here car is having engine and tire as a child objects, and then engine is having electrical component and valves as child objects, whereas tire, valves, transistors, chips are not having any child object. So these would be considered as the leaf objects. So any object which is containing some child objects would be considered as composite object, and objects which don't have any child object would be considered as leaf objects. So here tire, valves, transistor, chips are the leaf object. If suppose if you perform some operation on the child objects, for example get price is the operation, which is a method which can be applied on transistor object, chips objects, valves, tires. Here this get the price operation are being applied on all the leaf objects, then that operation should also apply on the composite objects called car, engine and electrical component. So you can get the price of transistor, get the price of the chips, get the price of valves, get the price of the tires, engines, electrical components, cars and etc. So here the operation which is applying on leaf object is also applying on the composite object and other leaves and other composite object. Then this would be considered as a composite design pattern. So these are the two principles and rules that are needed for qualifying the three structure of an object into composite design pattern. There are various criteria, there are various use cases where we would use composite design pattern in real life examples to solve real life problems. We will try to cover one of those real life problems using Java implementation in the upcoming videos. So please stay tuned to this channel. Now we are going to discuss about the decorated design pattern in a theoretical manner using real life example and real time example. In the next video we will try to cover the sample program to explain decorated design pattern in a detailed manner. So first, what is a decorated design pattern? So this decorated design pattern falls under structural design pattern. So structural design pattern, and then this decorated design pattern is used whenever an object needs to behave dynamically at runtime based on the request, then we can use decorated design pattern. So for example, this is a definition: additional responsibilities for an object at runtime. So we are adding additional responsibility for an object at the runtime without affecting the base object. That's important. Without affecting the base objects, that's the important point. So we will try to explain about this using some real life example. So for example, if you are going to some supermarket and if you are buying some cone, what you do is you would ask the customer, you would ask the food server to serve the ice cream based on your request. So this is a base ice cream or base cone. If one of the customers is asking I need some vanilla ice cream, so what that food vendor would do is he will try to use that base and then he will try to fill the vanilla ice cream. So here this is the base object. This base object is converted to custom object based on user request. So here the base object is added with some additional responsibilities. Here vanilla ice cream is the additional responsibility at the runtime. So this is one of those examples. Suppose another customer is coming, another customer is asking about, is asking that he needs the chocolate ice cream. So here the vendor is filling the chocolate at the runtime. Here chocolate is the additional responsibility added to the base object at the runtime. So this is the another scenario in a real life. So we will try to cover another example. If suppose this is the plain pizza, and if a customer is coming to the pizza shop and the customer is ordering, I need some chicken pizza. Here the food chef, what he would do is he would take the base object which is a plain pizza and he will add some extra responsibilities, in our case which is chicken, at the runtime dynamically. That's important, that's the more important when it comes to decorated design pattern. So decorated design pattern, when should we use a decorated design pattern? So whenever an object should be treated dynamically at the runtime based on some criteria, then we can choose the decorated design pattern. So we will try to cover decorated design pattern Java implementation in the next video. Please try to watch that video also for better understanding. So thanks for watching this video about facade design pattern in theoretical manner using real life and real time example. In the next video we will try to write a sample program to implement the facade design pattern. So first, what is a facade? In French, a facade meaning is frontage. So whatever you see is called facade. So the main motto behind the facade design pattern is simple interface to a complex system. So the system can be complex, but you need a simple interface to operate the operations. So another principle is single class represents entire subsystem. So your system can contain n number of subsystems, but the end user should see as a single thing. So the entire complexity should be handled by the inner implementation. You don't need to worry about that. So this is the main motto behind the facade design pattern. We can explain that using some real life examples. The first real life example is, suppose you are using ATM, if you are trying to withdraw some amount from ATM, for example 10,000 rupees. So what you do is you would insert your you would insert your bank debit card into the ATM, and you would give the required password, which means passcode. So here, once you do that, once you trigger 10,000 rupees withdraw button, then these are the following things that would happen behind the screen. So first it will check whether the account is valid or not, and then it will check whether your account has some sufficient funds for withdrawing 10,000 rupees, and then it will check whether your account your pin code is correct or not. So after validating all these things, then 10,000 rupees would be withdrawn from ATM. So these are the complex things that are handled behind the screen. For the user, for the end user, the interface is very simple. You can just click on some button and you can just give the amount that you need to withdraw. The interface is very simple. So this falls in the facade design pattern. So simple interface to a complex system. So another example is, suppose if you are trying to build a building. So for example, that building consists of 10 floors, and each floor should contain some 2 or 3 rooms like that. And then for the quality purpose, you would need to select the better bricks, cement, and etc. Here you would to build this building, you need to maintain many things, and that's a very complex process. So what you are trying to do is, you are trying to give this contract to the building contractor, so who would manage these things in a better manner. So what you do is, you are trying to give 50 lakh rupees to the building contractor, and you are explaining your use cases to this building contractor. Then this building contractor would handle these complex things behind the screen. The end user don't need to worry about this. This building contractor will worry and manage these things. So here this is another real life example where facade design patterns is applied. So here this is the end user need not worry about the complex things behind the screen for building this building. Everything would be managed by this building contractor. So this is another example where facade design pattern is applied. So in the next video, we will try to explain facade design pattern using some sample implementation using Java. So thanks for watching this video. Now we are going to discuss about flyweight design pattern theory, principles, and real life examples. In the next video, we will try to cover the flyweight design pattern practical implementation using Java. So first, the definition for flyweight design pattern is, it is used to create a large number of objects of almost similar nature. For example, if you are going to if you need some thousand copies of some data, the data is in our system. So what we would do is, there are two options. So first option is, we will try to get the printouts for 1000 times. So we will get the expected output, which means 1000 copies of actual data. The other way is, we can get printout of one copy, and then we can use that copy for taking the Xerox copies for other remaining 999 copies. So by doing the second way, we can save some amount of money. For example, if the shopkeeper is trying to demand 1 or 2 rupees for a copy for printout, then 1000 into 2 rupees, then the total amount that we need to pay to the shop owner is 2000 rupees. If we take one printout, and then if we if you ask the shopkeeper to do the Xerox copies of the for remaining quantity, which means 9999, then we could save nearly 1500 rupees. So in software angle, in software applications also, we can reuse something. If we can reuse something, then we can save memory. So by saving memory, it eventually it improves the performance. So Flyweight Design Pattern is one of those which saves some amount of memory by reusing the existing objects. So it is used to create large number of objects of almost similar nature. If the objects are in similar nature, then we can create n number of objects without expanding the memory, without bombarding the memory. We can reuse the objects. The second definition is large number of objects consumes large amount of memory. The second point is, so there is no large number of objects requires large amount. If suppose if one object requires 1 MB, if we require 1000 objects of the similar kind, then 1000 into 1, we need 1000 MB memory. Flyweight Design Pattern provides a solution for reducing the load on memory by sharing objects. The main principle behind Flyweight Design Pattern is share the object which can be shared. It is used to reduce the number of objects created and improve performance. So if you reduce the number of objects that are getting created, then we can eventually improve the performance. That is directly proportional. Reduce the number of objects, then improve the performance. So if you want the better performance, then you need to reduce the number of objects. And the fifth point is it reuses the already existing similar kind of objects and create new object when no object is found. So we can relate this point with the real life examples using Angry Birds so that you could get the information in a better manner. So for example, we would have played Angry Bird game at many times. So for example, we will consider this one of the Angry Bird. This is the base Angry Bird, which has 2 eyes, 1 nose, and 2 legs. These are the features of this Angry Bird. If we can reuse this object, if we need thousands of similar objects, then we can reuse this object. If we require a similar kind of object, for example, we need this object but of red color, then what we can do is we can use this object from the cache, and then we can apply the red color on the fly. So this is the power of Flyweight Design Pattern. So we can create n number of objects of this similar kind without expanding the memory at the runtime. So here we are reusing the object, but we are applying the additional features on the fly. So that's the point. It reuses the already existing similar kind of objects and create new object when no object is found. If a new Angry Bird of different dimensions is required at the runtime, for example, if a new Angry Bird with 2 eyes, 1 nose, and 1 leg, 2 eyes, 1 nose, and 1 leg. This is the requirement at the runtime. We don't have any objects of this kind. So what this pattern suggests is try to create a new object if it doesn't exist at the cache. So what it will do is it will try to check whether this object is already present or not. If it's present, it will try to reuse that object. If it doesn't present, it will try to create the new object at the runtime, and it will try to reuse for the next successive request. So this point, it reuses the already existing similar kind of objects and create new object when no object match is found. And then intrinsic states are constants and stored in memory, and then extrinsic states are not constants and needs to be calculated, and that are not stored in memory. So here intrinsic states are those things which can be saved in memory. For example, this is the one Angry Bird object and this is another Angry Bird object. Here 2 eyes, 1 nose, 2 legs are the constants that can be saved in memory. Here 2 eyes, 1 nose, 1 leg are constants that can be stored in memory. At the runtime, if we need 2 eyes, 1 nose, 2 legs Angry Bird with red color, here red color is extrinsic states. If we need 2 eyes, 1 nose, 2 legs Angry Bird with the blue color, here blue color is extrinsic state that can't be stored in memory because that are added at the runtime that would be used for that request only, so that need not be stored in memory. These are the some points about the flyweight design pattern. We will try to write a Java program for this in the upcoming video, so please stay tuned to this video. If you want to learn software design patterns in a detailed manner, then you can download the book. The book link would be present at the description box of this video. See about the proxy design pattern theory, principles and real life examples. In the next video we will try to cover the proxy design pattern practical implementation using Java. So first, what is a proxy? A proxy means in place of or representing or on behalf of. So this is the general meaning of proxy. So please try to watch this video completely so that you could get the proxy design pattern in a detailed manner, because I have included the real life example of proxy design pattern. So this is the real life example. This is the illustration of the real life example of proxy design pattern. So please try to watch the video completely before please don't skip this video. And then placeholder for another object to control the access. For example, there are two objects. So this is a real object. So this real object, the placeholder for another object to control the object. This is the real object. To access this real object, there is some another object. This is a proxy object. It will try to control the access. If suppose a client is trying to access this real object, this proxy object will come into act, and it will try to check whether client has its permission, and client can and other various, based on various criteria, this proxy object will try to reply to the client whether that client has access to this real object or not. And then the third principle, proxy is the object that is being called by client to access a real object behind the screen. So this is a client. This client knows only this proxy object. The client doesn't aware about this real object. This proxy object will try to manage the internal things, and it will try. This proxy object will try to contact this real object, and it will try to get the relevant information and data. And this proxy object will be served to the client. So this is the second. This is the third point. And then proxy pattern represents the functionality of another class. So this is the real object, real class object. The functionalities of this class object, the functionalities of the main object is replicated by this proxy object. Virtual. There are three types of proxies that are widely used in industry. The first one is virtual proxy, is a placeholder for expensive to create object. For example, and then the real object is only created when a client requests the access the object. For example, suppose if a client is trying to access the student data of a particular student. For example, the client is accessing the student ID 1 data. Here the student doesn't aware about the real object at all. It will see that there is some object. This is a proxy object. The client knows that there are some object that will be served for the request. The client will know the real object won't be created until the client requests the actual thing. Until the client requests. Till that time, this proxy would be shown to the client. When a client actually requests that. Then only the real object would be created. For example, student ID 1 is the actual request. During the runtime on the fly, the student ID 1 data would be fetched from database, and the actual data would be converted to the real object. That real object would be served to the client. So this is the procedure for the proxy design pattern, virtual proxy. And the remote proxy. Remote proxy provides a local representative for an object that resides in different address space. For example, if the actual data or actual object present in the various address spaces, the client doesn't aware about those things. The client knows there will be some object that will be served when we raise a request. So here the proxy object would handle those things. The proxy object would get the object from the better address spaces for the particular request. And then protective proxy. Protective proxy controls access to a sensitive master object. For example, I have already explained about this example in the previous video. If suppose if you're studying in college or some other institutions, you would have some lab session, and during those lab session you can access the internet. If suppose if you are trying to access social websites like Facebook, WhatsApp, like that, using your college or your institution network internet, then there will be some proxy server which won't allow you to access the Facebook server or WhatsApp server. Here this is acting as a protective proxy, is protecting the actual requests based on the various criteria. So we will try to relate this with the real life example. This is the best example according to me for explaining the proxy design pattern using real life example. For example, consider there is a person named John. He is trying to get 500 rupees from his account. So he is having an account in XYZ bank. So what it do is, he would have two options to withdraw 500 rupees from bank. The first approach is visiting the bank. This is the first approach. In the first approach, what he would do is, he would try to visit the bank and then he would fill the challan, withdraw challan, and he will try to hand over that withdraw challan to the cashier, and that cashier would check the credentials, whether the account number is valid or not, whether the sufficient funds are present or not, like that. After that, that cashier would return 500 rupees to John. This is the first approach. Here John is spending money as well as time for withdrawing 500 rupees. For example, consider John is residing at location A, bank is residing at location B. The distance between A and B is 5 kilometers. To cover the 5 kilometers, John is traveling using bike. So for that he needs to fill some amount of petrol. For that he needs to spend some amount of money, and then time. So to travel 5 kilometers, it would take some time. So by using the first approach, John is spending both money and time for withdrawing 500 rupees. This is the second approach. This is the second approach where John visits the nearest ATM and then he uses the bank debit card and he swipes that debit card in the ATM machine, and he enters the required credentials like PIN number and other stuff, and is entering the 500 rupees in the withdrawal category. Here that ATM machine will act as a proxy object. It will try to communicate with the real object called bank, and it will check whether that account has sufficient balance, and it will check the other credentials, and the bank real object will reply those information to the actual proxy object, and that proxy object would serve the data to John. Here the proxy object is playing the major role behind the screen. This proxy object is handling the request on behalf of us. So by following the second approach, John is saving both time and money, because nowadays ATM is present on every street. So he could save both money and time to withdraw 500 rupees. So in real life, we are using the proxy design pattern at every point of our life. In software applications also, we are following proxy design pattern for some use cases. So you need to first analyze the use case, and you need to check whether that use case could be fit with the proxy design pattern or not. So these are the things about the proxy design pattern. If you want to learn more things about the software design pattern, then you could buy software design pattern book. The book link would be present in the description box of this video. So thanks for watching this video.